Welcome to Beyond the Screen. I'm John Wally, and today we're starting a brand new series, something I've been waiting on for a while. We want to get into covering things beyond just how to set something up, how to configure something, how to run a scan, and really get into talking about how do I go through a step-by-step doing my job and integrating tools like Tenable OT, Security Center, Eymbr AI into one kind of role of helping us do our job in more efficient ways. Today, we'll be starting with vulnerability management as an example. We're going to walk through, we're going to look at an asset, we're going to look at the vulnerabilities on that asset. We'll tie that into something like to Security Center to do some analysis, and then we're going to use AI to really drive it home and work into our entire workflow. So let's go ahead and jump in. Let's start in the area of Tenable OT Security. After all, Tenable OT Security is going to be the thing that's watching our assets in our environment. It's going to tell us whether we have vulnerabilities. It's going to tell us any actions that we need to take. And so it's kind of the first thing that's going to be listening and working on our networks to make sure that we're really tracking our vulnerabilities in a system. I'm not going to get into event analysis or anomaly detection or incident response. We'll do all of these as a part of this series. We're just starting in vulnerability management first, and then we're going to expand from there as we go through this series. So this portion will be all about vulnerability management. So in that sense, let's go ahead and look at our inventory and figure out what our vulnerabilities are. In our dashboard for Tenable OT Security, what you're going to see is we have about 640 OT vulnerabilities that have been found. I'm going to dig into one specific asset today. There's a lot of ways you could go after looking at vulnerabilities. I could go and look at my risk and my vulnerabilities as a whole, for example. But today we're going to look at a single asset. If I go into inventory and some of the prep for this, I wanted to dig into a less known asset that we've done in any of these videos. And that is, if I scroll through, I will find this asset, Olympia. I'm going to go ahead and click on Olympia and see what I can find out about this asset in Tenable OT. So what I'll see is I'll have 3 different devices on my backplane for this asset. I can have the CPU itself, but I'll also have, looks like I have a couple of type of IO or communication adapters. I can tell that by these icons on the actual backplane as well. I can see what my IP address is, so then I can say I know how to get to that. I can see that it's a Siemens as far as who the vendor is, what the model is, the last time that we saw it, the family, and any current running firmware on that device. We'll get into other things that we can do later on with anomaly, like code revisions and ways to look at if anybody's messed with the ladder logic or the logic on the controller, any kind of attack vectors. But for now, like I said, we're focused just on vulnerabilities. So I'm going to go down to the vulnerabilities section for this asset. And number one, what you'll see is we've already fixed a couple of vulnerabilities, but that doesn't mean everything's been fixed. So if I go to active, I will see I still have 19 active vulnerabilities on this device. If I scroll down, I can actually change these in the order. Right now we have our severity from lower to higher. We could switch this so that we get our highest to our lowest. I could do the same thing around VPR. If you're not familiar with VPR or vulnerability priority ratings, this is a Tenable specific score. And what it tells us is how critical is the priority for fixing this. And there's some threat intelligence behind this as well. We'll do a whole series on VPRs at some point, but right now it's just good to know severity is based on things like CVSS score, where VPR really has some threat intelligence behind it. How active is the threat? Is there known exploit code? Those kind of things. So let's look at this critical severity. So I'm gonna go back and I'm gonna say put these in order of our critical severities, and you're gonna see we have the Siemens improper restriction of operations within bounds of the memory buffer. And there's a CVE associated with it. So if we were to look at this, I'm going to take note of a few things. The first thing is a plugin ID. Now, if I go down below, it's going to give me some information. I'm going to scroll this up a little bit just so we can see. It's going to tell me things like what port did I see this on, what's my version, what was my source, right? And I can even click on the actual vulnerability itself. But this doesn't give me a lot of information. If I click here to dig into this a little more, I'm going to get more information about this actual vulnerability versus the device itself. The first thing you'll see is we have 7 assets that are actually affected by this same vulnerability that we see on Olympia. This is going to give us more information as well, like what's the real issue with this? What's the solution? What are different resources that I have that this is tied to? Again, it's going to give me the plugin ID that found it, the date that it was published, the date that it was modified, and any kind of scripts or VPR drivers. One of the things that we said with VPR scores is it has some threat intelligence behind it. And so what this is telling us is how recent has the threat, how recent events have happened as far as out in the wild. Has this been reported to ICS CERT or something like that? Does it have exploit code? And what this means is Tenable as an organization has come in, they've researched this, they've looked to see if there's known exploit code that will work on this, it's unproven, and we look at the age of the vulnerability. Also things like product coverage, is it well maintained? Does Siemens actually push out patches for these types of things, that kind of thing. We look at the actual CVSS vectors, so we look at all the codes that are used in actually doing that scoring as a part of that as well. Any CPEs that are out there and CVEs. And here we will find our CVE for this vulnerability as well. So Tenable OT gives us some really good data just to begin with. Now we have tools like Tenable Vulnerability Management, or for on-site or on-prem solutions, you would have something like Tenable Security Center in place. You can link these together, and this lets you even do deeper analysis. So I'm going to go over to Security Center, and I know this is a new product. We haven't talked about this, but Security Center has been around for years and years and years. But a lot of times for dashboarding, reporting, analysis, Security Center is actually a stronger tool when paired with Tenable OT, and they integrate with one another. So one of the things I'm going to do is I'm going to go down to Analysis, and I'm going to go to Vulnerabilities, and over on this left-hand side, what you'll see is a little filter. I'm going to go to my filter, and I'm going to do a couple of things. The first thing I want to do is put in the IP address for the asset that I actually saw. So for Olympia, we know that that asset was .70. So I'm going to put in 10.100.70. And then I'm going to also put in that plugin ID that we saw before. If you don't remember that, I can go back through here and we'll pull it from right here. So I have that 500.484. I'm going to copy this and I'm going to put this into the plugin ID. And I'm going to say it equals that. And I'm going to hit apply. Now what we'll see is it's going to come up with the same information. It's going to say, okay, we have these vulnerabilities. I'm going to click into this and I'm going to drill down a couple of times so that I can see the vulnerability. And this is going to give me some extra information that I did not have previously. It's going to give me a description, but if you look, my description is a lot more verbose in Tenable Security Center than it was in Tenable OT. If I scroll down through here though, I'm going to get something unique that I didn't necessarily see in the other side, and that is my plugin output. So we know the way that we found this was by looking at the device and pulling in both the family and the version number that'll line this up with this publication that said, hey, we have this problem. So now we've dug through here. We know what our actual fix is, because if you look under solutions, we'll see this here where it says state our actual steps to remediate. But here's the thing, this may be a point in time. There may be things that supersede this. There may be better things that we find out in the wild. There could even be problems with the solution that a vendor may have put out there. So one of the first things I want to do is go over to Eymbr AI, because Eymbr AI is also integrated with our Tenable OT environment. So if I go over to Eymbr AI, I'm actually going to ask Eymbr to go in and look at this device and tell me what she can about it. So I'm going to go ahead and say, hey, can you look at this asset, Olympia, and tell me what you know about the device in detail? What she'll do is go out and look at that device based on Tenable OT data. And so what you'll see, she's working through all of the information on the back end, and she has this thinking capability as she goes through. She's not only going to be looking at Tenable OT data, but also looking at things like, does it align with certain industry requirements or regulations? Today, she's actually tied into things in the nuclear industry. But what you'll see here is basically it pulled the information from over and says, okay, here's our firmware version. You'll see this matches up at 182. We know what the IP address. We know that it has a risk score of 65, meaning it's a moderate exposure, right? And we saw some things like final year support, and we saw that on the other side. We have our list of CVEs that are out there and the number of vulnerabilities, right? And any patch management stuff that's out there from a recommendation point of view. So this is going to kind of pull some of that information together for us. Instead of having to go from one platform to another, trying to figure things out, we can actually drive through and look at these individually. So I'm going to jump forward a little bit and say, I want to look into one specific CVE. So I'm going to say, can you research the CVE that we saw, the critical one, and I'll see where it aligns with basically the research that she can find on you accessing the web versus aligning with our Tenable data. So I'm going to go in here, I'm going to say, hey, can you research the CVE in detail and make sure it aligns with that Tenable data? And what she'll do based on this is she's going to take what she's learned, she's going to pull in that data for 8.2 vulnerability, or CVE, and then cross map that with anything that was found out on the web. And so because there may be something newer that we found, not just how things are mapped to MITRE, which our other stuff didn't give us. It is actually gave us more information when she came back. So what ended up happening is it went out and it said, okay, we looked at this. We saw that it was a memory buffer issue on this. Olympia has this, right? That is listed, plus 7 other assets that are out there. And it tied in what the different assets are. And then it said, here's where it's in alignment. So it read the Tenable OT records and it confirmed the vulnerability status. So that is there, right? The severity and the solution. So what its recommendation is to go through and prioritize patching of this to mitigate this critical vulnerability. So this has given us 3 ways to look at the same data and really make sure that we're not seeing a false positive, to make sure we saw it in real inventory, to make sure that the vendor's website is saying that this is still a valid thing that needs to be fixed. And it's saying that the best way to do this is actually go through with patching. But we want more specific details. So what I'm going to say is like, does the vendor, does Siemens, for example, give us a specific instruction on official fixes? We know that Tenable did, but what does the vendor say? So I'm going to go in and I'm going to say, what does the vendor say for official fixes for this particular vulnerability on this particular asset? So what we're doing is we're digging in little by little, investigating what it's going to take to fix this vulnerability. And hopefully this helps like when we're going through all of this too. So the way Eymbr ties back information, look at how it cross maps to things, look at how this could also be affected with events that are going on the particular system, and then what we need to prioritize. In this case, is saying patching. But we may not always be able to patch, right? So once she's looking into this, knowing an OT environment where we're not necessarily able to go out and do that patching, we may be tied to certain timeframes that we can do that. So what Eymbr's come back and said, yes, there's an official firmware update for this, for the guidance. Now what we're learning is that we need this firmware update in order to do it. So immediate patching is not, if that immediate patching is not feasible, there's other advice like network segmentation, password protections, blocking remote clients, those kind of things. Well, let's say that we're already fairly well segmented in our environment, right? And passwords may or may not be able to be used here, but let's say that we don't have a maintenance cycle for like 3 months, and we know that. So I need to know, like, what do I need to know? What do I need to tell my lead engineer to do to make sure that either we can fix this, maybe we can fix this depending on software versions, which is some of the stuff that we're seeing in here. And then, like, what do we really need to do? So what I'm going to do is I'm going to put a prompt in here that will get her to do some of that research for me. So I'm basically going to say, we don't have another maintenance cycle for 3 months. And at that point, we'll switch to our train B and we can fix the device. What do we need to do to make sure that we don't run into any problems? And can you research this fix? They have others have run into issues implementing it. So we understand that the vendor's saying that we need to go out and upgrade the firmware, but there could be other problems that stop that. And I've seen this over and over, especially people coming from an IT background. We're doing things like patching Windows servers is hard enough, but doing firmware upgrades could do lots of things, like saying that our software version and our firmware version don't align, and that means we need to do a software version upgrade first, which could cost thousands and thousands of dollars. So understanding the problem a lot of times is the gap. But if I'm able to prompt Eymbr in a way that says, hey, what are the gotchas in this? What do I need to think about? What are some of the issues that I might run into with this? And then she can really dig in and tell us, this is what you need to do. And so it's this way, when we start going into really digging into this, we can find out what those common issues are, right? And so there's a good bit of stuff in here, but what we need to do for pre-maintenance is, first of all, we need to verify compatibility. We need to confirm that Olympia-specific models are compatible with the actual firmware. Now, why would it not be compatible? Like, didn't Siemens say to put this on that device? Yes, but this is a common misunderstanding when people from IT try to go in and say patch things in an OT environment. Not all modules are compatible, even if the vendor says that that is the fix. What that means is you may have to go buy a whole new communication module or CPU or whatever that is that supports that firmware version. That means not only now do we have a patch, we have a hardware replacement. And only 3 months to do it. That means it might it might take us a year to get this patch in place. It's something to be aware of. Also, like, is there some way that we can back up that data? Can we actually look at what the logic is on it? Can we go in and look at, like, to make sure that our data and our separate memory cards, can we take snapshots, those kind of things? Can we prepare tools for the environment, right? As far as, like, what software versions do we need? What alarms, what interconnects do we have? And then we need to actually plan for that downtime. Now, we said we have an outage where we can move over to our train B in 3 months. The question is, do we have time to prepare for that? And then during the maintenance, we need to use a dedicated memory card, update via the portal, enable web server if needed, because sometimes that is, and then monitor for errors. And then there's post actions as well. And then she gave us a little bit of information on the back end on why it said we needed to do it the way we do it. Problems that other users have run into when doing this. So we can say upgrades are failing due to insufficient and free space or corrupted cards. And, we have a TIA portal incompatibility. So as we dig through these, it's going to tell us more and more, and this is going to help bridge the gap. If I'm sitting somewhere in vulnerability management and I have to do both IT environments and OT environments, sometimes this is really hard to describe to our typical IT resources on why this is going to be a problem. It's just a firmware update. Don't we do firmware updates on PCs and stuff all the time? And while that may be more involved than doing just a software patch, like, it's not that big a deal, but it can be a big deal when we're talking about controllers and OT environments. And what you're seeing is it can impact memory, it can impact hardware replacements, it can impact software version versus hardware version compatibility. And so what this will help is, because Eymbr's trained on these environments, she can actually go in and say, here's what you need to look out for. Now that we know that we have all these common issues that come up, the next thing is, like, I really need to let my lead engineer know. So let's pretend we have a lead engineer, Sarah, and we need to draft an email to Sarah on, like, what do we need Sarah to check on? And also, what do we need to implement this, and can we get this into the next maintenance cycle? It may not be possible. So what I'm going to do is I'm going to ask Eymbr to draft that actual correspondence. I'm going to say, my lead engineer needs to know about this and we need to plan for this. So I'm asking Eymbr to draft an email stating what we need and to verify whether we can implement this fix if possible. And can we slate it for the next maintenance cycle? And then I said, oh, by the way, her name is Sarah. So now what Eymbr can do is actually go out, draft that email for me so that I can go and send that out and start tracking it. As she walks through this, we've gone from the discovery, looking at the vulnerability, looking at the asset, doing our research on that vulnerability, all the way down to sending an actual email that could say, here's the things that we need to look at. And so you'll see that she put in a subject. We've identified what the asset is. We need to prepare for addressing this critical vulnerability on Olympia asset. We said what that is during the next maintenance cycle in the next 3 months. We want to ensure a smooth implementation and avoid delays. So here's what we should verify and plan for. We need to do a compatibility check. We need to do backup and testing. We need to do tool and resource readiness. We need to do a maintenance window coordination. And then we have to have some kind of rollback plan. And we even talk about, here's some of the common issues to anticipate. Best regards, and then my name. And I can take this and put it into my email and send that off. Hopefully this has been a helpful exercise. Not just talking about how the tools work and how we can integrate them, but how they can actually make us better at our job. By taking tools like Tenable OT Security, taking vulnerability management for things like Security Center, and then integrating with a tool like Eymbr AI, where we can go from beginning to end. From that initial, we found the asset with the vulnerability, tracking that vulnerability, and then driving all the way through to our email to our lead engineering. If this has been helpful, click that like button, hit the bell if you want to get notices when we release these. We're trying to get these out at least once a week. And until next time, have a great day.